Hi, this is Adil. Today's topic is pressure. We'll start this topic, but before starting the actual topic, I would ask you: have you ever heard about the word in your daily life? Obviously, might many of you have heard this word in different ways. Say, once your father comes home with a pile of files, and he sits on the system, and he's doing his work, and one of your younger brother sister goes to him and says, Baba, father, daddy, I need blah 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 blah. What he says usually, he says, hey kid, don't disturb me, I'm under pressure, I have to do a lot of work. This is one example. You might have encountered this situation that you go to a garden, and the gardener is like watering the plants. You might have heard this word over there. There's low water pressure, there's a high water pressure, and like that. You go to a gas station, your father is filling the gas, or the person or the attendant over there is filling the gas. Then your father would have asked, what is the pressure? Is it a high pressure of the gas or the low pressure of the gas? And like that. So a lot of examples are there. So what pressure in physics is? In physics, when you talk of pressure, first of all, remember one thing, that in Cambridge, this is a very important topic. It belongs to the journal physics part, and around 2 to 3 MCQs usually comes from this topic, and either a part question or a full question sometimes taken from this topic. So very important topic. Now, a pressure. When we say pressure, actually it is the outcome. It is the the result of the application of a force over an area. When we say force, the force can cause a lot of things. The force can cause a change in displacement. A force can cause a change in shape, that is you call deformation. A force can cause a change in direction, that you call turning effect. Similarly, a force, when it's applied over an area, it causes a physical phenomena, we call it pressure. So one thing we got, that pressure is due to force being applied over an area. Now, what happens when a same force is applied over a different area, or different forces applied over a same area? Let's discuss this situation one by one. So say, let me give you one example. Say I have one situation in which a kid, a boy, small boy, is applying a force with the help of his finger on a notice board or a soft board. On the other side, in the number 2, for example, the picture number 2, the same boy is applying a force or almost a similar force onto the same notice board, but right now here he is applying the force with the help of the whole arm, or the whole palm. The palm is on the paper, on the notice board. Now, my question: if we assume that the force being applied in both the situation is same, then where there would be a higher pressure? Now, a person who has no link with the physics would say that in the second situation, since it looks like the whole arm is being applying a force on the force on the board, so it is causing a higher pressure. But in physics, this is not the case. In physics, pressure is responsible on both the parameters, force and area, but when we say same force, then it directly goes to the area. So, and it depends inversely on the area. How? Let me explain. Say, in the first situation, the arm that was applying a force with the help of the fingertip on the board was exerting a force. Now, the transmission of force was channeling on the board with the help, at the point of contact, which was just the tip of the finger. So is it a small area or a larger area? Obviously it's a small area. So this small area will create a higher pressure. Okay, and that you can easily observe in your daily life. If you go home, just place a finger on your mattress, on your the bed on your sleep, you will find when you apply a pressure with your finger, it goes much deeper as compared to when you apply a force with what you call it, your thumb, the whole palm. In the second situation, when the same force being applied with the help of the whole palm, now here what happens? The palm covers a larger area, and when the area increases, the pressure decreases. Why? The question comes in mind, why? Because in physics we say pressure is defined as the force acting normally per unit area, and force and pressure depends inversely on the area. So it means if the same force is being applied onto an area, so depending upon the contact area or the effective contact area, if the same force is being applied, then larger the area, less the pressure. Small the area, more the pressure. Why? Again the same situation, same definition, because pressure is a force acting normally per unit area, and you can calculate it with the help of this formula, which is pressure is equal to force over area. Now the formula shows clearly that pressure depends directly upon the force. Larger the force, more the pressure, less the force, less the pressure. And pressure depends inversely on the area. It means the larger the area, less the pressure, smaller the area, the higher the pressure. Now, pressure, and I'll show you some questions which I have taken from the Cambridge, which will use the application of this concept of the pressure. Okay, mind it, this is actually a general formula for pressure, but technically this formula is mostly used with the solids. Okay, so here two parameters are being used, force and area. Force is measured in newtons, area is measured in meters squared in SI units. So the SI unit of pressure would be Newton per meter square. So we say the pressure is measured in Newton per meter square, and we give a new name to this whole unit, which is called Pascal, as per the name of Sir Blaise Pascal. So 1 Newton per meter square is equal to 1 Pascal. So we can say a force of 1 Newton will create a pressure of 1 Pascal when it is applied perpendicularly over an area of 1 meter square. Now this is the SI unit of pressure. However, pressure is also measured in newtons per millimeter square or Newton per centimeter square. Till here, is it okay? Great. Say if you are given a situation in which again the three parameters are there, and say you are going to find the force rather the pressure. Pressure is given, area is given, you are going to find the force, or the two parameters are given, you are going to find the area. Right, so we have this triangle here. Now this triangle is used to derive the formula. If, for example, if you don't remember the exact formula and you have the triangle in your mind, then simply place your thumb on the number, on the symbol that you are going to calculate. For example, pressure. When you place your thumb on the pressure, if you hide the pressure, then the formula with the left is F over A. So means P is equal to F over A. Similarly, if you are going to find the force, then place your thumb on the force, then F would be equal to P times A, and similarly you can find the rest of the area and like that. Now this is the application, this is the formula of the pressure. Now we'll find some everyday application of this concept of pressure. Now obviously, being a student, you carry bags, you carry school bags. Now when you come to the school and you are carrying a school bag, you put the bag on your back with the help of the straps. Now the wider straps, actually what they do, they distribute the whole weight of the bag over your entire back. So it means larger area over the shoulder will distribute the force, so less pressure is being exerted. This is one of the situation. Second situation, very common, and in most of the books this situation is given. Say there are two people, there are two ladies. One is wearing a high heel shoe and the other is wearing a flat sole shoe. Now which lady will find it easy to walk? Obviously now modern ladies can walk easily with a heel as well, but my question normal is that we will find that it is really difficult to walk smoothly with this high heel, and there are more chances that the heel will dig into the soft ground as compared to the flat sole shoe. So why? Again the same situation. The high heel, since the contact of the heel with the ground is very small, so small contact area will create a high pressure. On the other hand, the flat sole shoe, the larger area will create small pressure. Now we have three more situations. Now you might have found that this vehicle, like this tractor, now this tractor, this is in the fields. Now why we have these huge and wider tires? Now, since this tractor has to work in the soft ground, other than the concept of stability that you might have discussed in your early classes, other than the concept of stability, the wider tires or the larger surface area is used so that the tires should not sink into the soft ground. Now, we need the knife. We need the knife for cutting fruits or some other things. Now, we need a tool that should cut the thing with least amount of force. So, to cut a thing with the knife should be sharp enough. Now, the edge of the knife or the side of the knife that is in contact with the object to be cut is actually very sharp. So that sharp contact gives us a very small area. It means a higher pressure is applied. So smaller the area, higher the pressure. And same is true with the top figure. Top figure, can you see here? Yeah. The wooden or concrete sleepers are kept below the railway line. Now why? You know, a railway track, what runs on the track, or a railway carriage, I mean, it's a very, very heavy vehicle. The chances that due to the very high amount of weight of the vehicle, the track can sink down to the ground. So to avoid that thingy, what they do, they put this larger sleeper or this larger wooden or concrete sleeper below the track. So what it does, it distributes the weight over the larger area, causing a small pressure or causing a reduction in the pressure. So these are the application of the formula P is equal to F over A. Let's see how Cambridge takes this formula in its papers. Now these are the different questions I have collected for you. I have taken these questions from different years. Now say on the extreme left hand side of your screen, this is question number 11 marked here. Now it says a student uses her thumb to push in a drawing pin, say a thumbtack, into a notice board. Now the pin goes into the board but doesn't penetrate her thumb. Which statement explains this? Now, keep in mind that P is equal to F upon A. Larger the force, more the pressure. But if force is same pressure. But pressure depends inversely on the area. Larger the area, less the pressure. Less the area, more the pressure. So, keeping this formula in mind, we check all the four choices. Now, A. Choice A, the force exerted by the pin on her thumb is greater than the force exerted on the notice board. C, the thumb pin is actually a channel through which a force is being transmitted. So, irrespective of the shape of the channel, the same force will be transmitted to the notice board, because for the arm being applied, the force is being applied through the arm, and arm is the same. The pin is the channel, a transmission guide through which the force is being applied or force passes. So, the force doesn't change actually. So, both A and B are wrong. Force is not greater or not smaller. So, go to C and D. Part C says the pressure of the pin on her thumb is greater than the pressure on the notice board. Now just keep in mind, just take image in your mind about the thumb pin. Where is the sharper end? The sharper point of the pin is always towards the board. Now the sharper pin is having a very small area. So where the higher pressure would be? Towards the board, towards the thumb? Obviously towards the board. So the C says the pressure of the pin on her thumb is greater. Obviously wrong. So go to the D. The pressure of the pin on the notice board is greater than the pressure on her thumb. Yeah, exactly. That's true. So D is the right answer. The next question. A solid cube has sides 0.50 meter long and a mass of 120 kg. It stands on the ground on one face. What pressure does the cube exert on the ground? Here you will need the formula or the triangle that I showed you. P is equal to F over A. Let me go back to the same formula. Yeah, here. P is equal to F over A. Since we are going to find the P, so formula would be P is equal to F over A. Now just go back to the situation. Now we have a cube. Now we know that cube has all the same faces. All sides are same. So area of any of the side would be 0.50 times 0.50. That goes to 0.25 meter square. And 120 kg will create a weight, a force of the exerted by the cube would be 120 times 10, because we'll take the value of G as 10. So 120 times 10 goes to 1200 newtons. So plug in the values in the formula. So P is equal to F over A, 1200 upon 0.25. The answer would become 4800 newton per meter square. So C is the right answer. And similarly, you can go to the extreme right hand question, where is again the number 11. It says the diagram shows the box of dimensions 6 cm by 8 cm by 4 cm, and the question is that on which face must the box rest to exert the least pressure. Now what is the keyword? The keyword is least pressure. So just again bring the same formula in your mind and check the relation. Pre is inversely to area. Larger the area, less the pressure. Now check which face has a larger area, x, y, or z. Now the face x has a larger area because 6 times 8 goes to 48 cm square. So that's the largest area in all the three faces. So face x is the right answer. So you see that this formula P is equal to FA will give you a quite clear way to get the right answer. So please keep the formula in your mind, keep the relation in your mind, that how pressure depends upon the force and pressure depends upon the area. Alright, this is, as I said you earlier, that pressure, we are discussing this formula in under the heading of pressure in solids. Okay, so mostly this formula is used for solids, but does pressure relates to solid only? No, pressure is present in liquids, pressure is present in fluids, pressure is present in gases. So let's go to the pressure in liquids. Now, how many of you swim? Or you know I'm swimming? Obviously many of you. So when we say, I'm sorry, off the screen. When we say if someone is swimming in a pool, then he or she would have felt that when the guy is in deep water, he feels a higher pressure, and when he comes on towards the surface, the pressure on top of him reduces or decreases. So it means that as you go deep, as you go down, the pressure increases. So, and there are some other factors as well which are associated with the pressure and fluids. We'll discuss each of them one by one. So starting with the first, the weight of the liquid causes pressure. Now say there is a container. Now in that container there is some amount of water, and the water will cause a pressure on the base of the container. What will happen if I add more water? Obviously when you will add more water, the pressure on the bottom will increase. Why? Because more water will create more weight, and more weight will cause more pressure. Again the same formula, keep in your mind, P is equal to F over A. Great. Now other than this formula, there are certain other features which are related to the pressure in liquids. Let's discuss them one by one. Now, if there is some person, some point, some object in the liquid, then points or the objects at the same level of depth will feel the same pressure. Also, points or objects which are at some level in fluid will feel same pressure exerted from all the directions. That is, the fluid or the liquid will create or will exert the same pressure from all directions on that point, on that object. Alright, number one. Next point that is very important actually is that I mentioned earlier, that when you swim deep you feel higher pressure, when you come on top you feel less pressure. Why is it so? Say you change your pool to this cylindrical vessel. Say it's a huge cylindrical vessel containing again some water, and you are offered to swim in that container. Now when you are swimming, and say we have three dots here, three positions, position 1 top, position 2 middle, and position 3 bottom. So when you are swimming at the top, the amount of water on top of you is lesser. And when you are swimming at the bottom, that is the third point, then the total amount of water on top of you is huge. So that's quite obvious that larger amount of water will create larger pressure, and small amount of water will create less pressure. So if you go down right from the top, dot 1 to dot 3, your pressure will start increasing. So we say that pressure increases with depth. As you go down in the liquid, pressure will increase. This is a very important point. Then another point, pressure doesn't depend only on the depth, rather pressure depends upon the density of the liquid in which the object is placed. Objects with higher density will create a higher pressure. Objects with smaller or lesser density or small value of density will create less pressure. So similarly, you might have found that it is easy to take out a spoon which is placed in a glass of water as compared to a spoon which is placed in a jar of honey. Other than the concept of viscosity that you will discuss or might have discussed in your earlier lectures, other than the concept of viscosity, it is difficult to take out the spoon from the honey because of the higher density. So it will create a higher pressure on the spoon. So it feels difficult to take it out. Anyway, so pressure depends upon the depth, pressure depends upon the density, and since we are on the planet Earth, so gravity is there. So pressure also depends upon the value of the g, that is the acceleration of free fall or the acceleration due to gravity. So we will combine all these parameters into a formula in the next slide, inshallah. Now here, this is a very important point. Sometimes people get confused that a larger vessel will have will exert a higher pressure, and a very narrow vessel will exert a low pressure. No, this is not the case. When we talk of the liquid, then in liquids, mostly the pressure is independent of the shape of the container. Why did I say mostly? If you have 2 or 3 different containers and all these 3 containers have the same level of water, then obviously it is independent of the shape of the container. But if the level of water is different containers, then it doesn't depend upon the shape, then it doesn't depend upon the depth, rather it will depend upon the amount of liquid. Anyway, so here we are shown a continuous container containing some liquid. One point to be noticed is that the depth of the liquid in all these openings is same. It's a continuous container. So no matter you are at the bottom of container 1 or 2 or 3 or 4, you will feel the same pressure as long as the depth of liquid on top of you is the same. Alright, that's great. So we discussed that pressure depends upon the depth, pressure depends upon the density of the liquid, and pressure depends upon the gravity. So let's join or combine all these parameters in one formula. So here comes the formula that gives you the pressure caused by a liquid, or pressure of a liquid, or pressure due to a liquid. P is equal to rho g h, or pressure is equal to h rho g. P is the pressure of the liquid exerted by the liquid. H is the level of depth at which the object is, means depth of liquid. Rho is the density of the liquid or the fluid, and G is the gravitational field strength or acceleration due to gravity, which is 10 syllabus. So we can calculate the pressure at a certain amount of depth of liquid provided we know the formula and the concept, obviously concept. Now I have collected some questions from the past papers so that to give you an idea how these concepts are asked in the exam. Say extreme left hand side again. 2 identical fish tanks are filled to the same level with water. One tank contains fresh water, the other tank contains seawater. Seawater is more denser than fresh water. Which fish experiences the greatest pressure? Now, 2 containers, one with the fresh water, 2 fishes, one at top, the other is at bottom. Second container, seawater, again one fish at top, second at bottom. Now, pressure depends upon the 2 parameters h and rho, that is depth and density. Now obviously the deeper fish will have more pressure, so either C or D. The second parameter, which is the density, so as the statement says, seawater is more denser than the fresh water, so obviously density in the seawater container is greater. So the right answer should be D, correct. D is the right answer. So why? Because the container has more density of fluid and the fish is at a greater depth. So more depth and more density will create a more pressure on the fish. Great. Similarly, we have next question and the next question. Just I'm giving you as a task. Tell me which is the right answer in the bottom question and on the extreme right hand question. Which is the right answer? Take your time and tell me what is the answer. For that for that moment, I'm taking a break. Okay, thank you very much.